Okay, so let's talk about some key points that we discussed while covering this chapter, just so we are in the position to talk about the past paper questions. Okay, transformations of functions. We know we have three different types of transformations. It could be that your curve is being shifted from one point to the other, but you guys need to understand that at times it would look like shifting, but actually it would only be stretch, just like the past paper question we discussed yesterday. I'll get back to that. But firstly, you need to identify the difference in translations. We are shifting in stretch. The size would change, either it would get big or the curve would shrink. Okay, so in case of enlargement, you should know that it's stretch. And the last one was reflection, where basically we were just getting the mirror image of our curves. Okay, so this is the idea behind this chapter. Now at times you guys will notice that there would be a curve, and through reflection and translation you would be getting a transformed image, but it could be that the other student thinks it's you are just stretching it or stuff like that. Okay, so this is what you need to understand. You guys can have different transformations and still the new function could be same. This is the idea behind this discussion. Anyways, I'll come back to that later on. For now, the important point is to revise all the key points. So forget about everything, just focus on this part. Okay, key point number one, this is basically for translation. The graph of y equals f of x plus a is a translation of the graph of y equals f of x by the vector 0a. You guys need to understand, if the translation vector is 0a, when would be the translation vector 0a? Whenever you will move your graph a units up. Okay, a is for y. Whenever we are translating it along the y-axis, either the graph would move up or it would move down. So for that, you need to add a in the actual function as well. So this is what I wanted to talk about for this class. This link. 0a means we would be adding a in the function because this is basically along y-axis. Similarly, if I talk about the second key point, now you need to notice that we just erase this. Okay, now you need to understand, it says the graph of y equals f of x minus a is a translation of the graph of y equals f of x by the vector a0. Now, what is the difference? We have a over here. This a implies that the change has been made along the x-axis. Your graph would either move right or left. It says positive a means your graph has moved towards the right side. For example, if red curve was the original one, so if I am moving it to the right side, as in 3 units to the right side, this would mean that I have shifted the red curve 3 units to the right. So in the translation vector, I am going to write it down directly. In translation vector, I would write it down as positive a. But I told you in the equation, it would be other way around. It was x minus 3. Okay, so for x minus 3, our graph was shifting 3 units to the right. And because of that, on the translation vector, we were writing it as positive 3. For this one, it would be positive 3 and 0. And when it was x plus 3, so for this case, the translation vector was minus 3, 0. Why? Because for plus 3, the red graph was shifted 3 units to the left. When our graph is moving 3 units to the left, on the translation vector, I'll write down minus 3. So translation vector is exactly how things are. On the equation for y, yes, we write it down directly. For x, it's other way around. Okay, this is the important thing you need to understand. Any confusions with this thing?
No, miss.
Rough, okay. Munja and Ahmed?
No, miss. Thank you.
No, ma'am.
Okay, all right, perfect. Okay, and then um, key point number 3, where we had, both the translations in X and Y. So the graph of Y equals f of X minus A plus B. This plus B is genuine. It means our graph would move B units above. So we have B here. But this minus A is not genuine. Whenever we have minus A, it means my graph would move those many units to the right side. That is why we have an A here. Okay, so you need to understand the difference between the both. Okay, then we discussed reflections. Reflections were like, this topic was easy. Here, the graph of Y equals minus f of x is a reflection of the graph of y equals f of x in the x-axis. So this is what you need to remember. If the line of reflection was x-axis, in that case, minus would come with the function, because in all the past paper questions, for the first part, they would ask you to comment on the transformations, and on the second part, they would want you to write down the transformed function, the equation of transformed function. So that is why this thing is important. Okay, if through graph you guys were able to observe that the reflection was along x-axis, this minus is not going to come with x. This minus is going to come with the function. All right, then the next one was the graph of y equals f of minus x is a reflection of the graph of y equals f of x in the y-axis. So imagine you had some graph, and it looked like the transform function was a reflection of the original one in the y-axis. So for y-axis, minus is going to come with x. Okay, please remember these differences. Okay, all right. And then we discussed stretch. So what was happening in stretch? Our graph was basically either it was getting bigger or it was getting smaller. So it was not necessarily a stretch. It was not necessarily an enlargement. It was also, reducing, the size was also reduced at times. So, but still we call that enlargement and we call that stretch. But the stretch factor and the enlargement factors used to be different. And I'm pretty sure you guys have done this in O levels as well. Okay. So again, the key point, the graph of y equals a f of x. A f of x means you're doing something with the function. You're multiplying this thing with the function, is a stretch of the graph y equals f of x with the stretch factor a along y-axis. Okay, so for y, first of all, it would be stretch along y when you're multiplying the number with f of x directly. Number two, the stretch factor would be this number directly, as long as you're multiplying this number with the function, right? But things would be other way around when you would be multiplying this number with x. Here what's happening, the graph of y equals f of ax is a stretch of the graph of y equals f of x with a stretch factor of 1 by a. So when the shape of the graph would be shrinking, this basically means that the stretch factor would be 1 by a, but on the original function, how are we going to represent that? By multiplying this a with this x, okay? So the stretch factor and the translation vector is going to give you a picture of how things are. But for the equation, you need to understand that. For x, it's opposite. If the image is reduced by half or by 2 times, it would actually be this, that you were multiplying 2 with x. Okay, so this is how things are over here. All right, okay. Yes, that is it. So these were 6 key points that are important in order to talk about the past paper questions. Okay, all right. So let me just shift to the past paper questions. All right, okay. Now this was a question that we were discussing. We are done with the first part, but I wanted to mention something. This is what exactly I was talking about in the beginning of the class. Okay, imagine that, like, for example, we did not have this part. We only had the green one and the blue one. Okay, now at times I've noticed, just because seeing that from 1 this has moved to 3, students say that this blue curve was basically transformed after a stretch, because obviously it's enlarged, and after a translation in along y-axis. But that is not true. Okay, at times stretch would look like as if there was some translation as well, but you need to make the stretched version of it and then think about it. Also, in yesterday's class, the translation vector, the students were saying that the translation vector would be, so it has moved 2 units above and 1, 2, 3, 4 units to the right. So some of the students were saying it would be 4, 2. Why were they saying this? Because it looked like the graph also translated along the y-axis. However, that was only the stretch. In the examples that we have been discussing, why were things not like this? Because I've been telling you guys already, whenever the translation is along y-axis, x-intercept has to be fixed. Imagine that you have some nail on the x-intercept points and then you're stretching. That made sense. But for this example, we did not have any x-intercept. Everything was in air. This part was not on the x-axis, so we did not have any x-intercept, and that is why we thought that this blue graph was basically made after a stretch and after translation. However, this was not the case. This was only stretch. So the good part is, and the important part is, you need to apply the stretch first. Okay, do not apply translation first. I have been telling you guys already, at times if you do translation first and stretch later on, your answer would still be fine. But the best practice is to go do things using BOD mass. We know that for stretch we are multiplying something with the function, and for translation we are adding, subtracting with the function, right? So good practice is just do this part first and then think about this part. Those who said it would be 4, 2 and then applied stretch, that also made sense. But obviously, if you do it this way, it would not make sense, right? So although both the transformations would be correct, but still a good practice would be if you stretch the image first and then translate it. Okay. Yes. Any confusions with this one? This was something that we discussed yesterday. Yes, please tell me. I shared the recordings, and if you had anything after watching the recordings, it's completely fine. No question? Munya, Ahmed, and Rafe?
Miss, like, wait 1 second.
Yeah, sure. Take your time. I'll zoom in.
Miss, I'm not getting how the stretch caused the translation itself.
Yes, okay. That's a good question. I'll tell you. Okay. So, how were we stretching? Okay. The examples that we have been discussing basically had some x-intercept, but forget that. Just think about it as a new concept. Whenever you want to find out the stretched image or stretched version of the graph, it's just this. I have the black graph, that's the original one. Okay, I have 3 points: the green dot, the yellow dot, and this red dot. Okay, green one, and then the yellow one, and then the red one. What was happening here? Where exactly? Yes, okay, here it is. This length is 1 unit. This length was 3 units. So one thing was clear, that the stretch factor would be 3. Any confusions with this?
No, miss.
Okay.
No, ma'am.
You know that the stretch factor would be 3. That part is clear.
Mm-hmm.
For finding out the stretched image, you're just supposed to multiply the y coordinates of all these points by 3 and then make the graph. For example, this was 2. 2 multiplied by 3 would give you 6. This was again 2. 2 multiplied by 3 would give you 6. And this was 1. 1 multiplied by 3 would give you 3. So I will multiply you for making the transformed images. Just pick up some random points of the graph, make them again, and then make your lines. Okay. So after having a point at this point, and over here, when I made the graph, it actually looked like a stretch, and it was translated as well. And why? For our examples and the way we have been discussing, why couldn't we understand this thing earlier? Let me just go and see if it had stretch. Yes, just look at this example. Okay, you guys can know when we are doing 2f of x, like at this point 2f of x, it basically means stretch by 2 along y-axis. And this diagram is only for stretch, it's not for translation. Okay, I did not include the translation diagram. We could feel genuinely that this is stretch because the original position of the graph was same. And why was the original position same? Because the x-intercepts were same. And why were the x-intercepts same? Because on this, no, let me use red color. On this red point and on this red point, what is the value of y? The value of y would be 0. Obviously, on x-axis, the value of y is 0. And when I will multiply this 0 by 2, I would again get a 0. That is why these points were fixed. And in all the examples that we have been discussing, the concept was understood this way, that for stretch, the diagram or the graph is going to remain there, and then it would look like we're just pulling it. Yes, that would be the case as long as you have your x-intercept or y-intercept if it was along x-axis. Okay, but since the example that we discussed did not have any x-intercept, and the basic idea behind stretch is you need to multiply all the points by the stretch factor. So even if I multiply the 0 by the stretch factor, because it's 0, I would get a 0. That is why I was not able to understand that for stretch, it could be that my image is going somewhere else and then stretching. Okay.
Okay, miss, got it.
This was basically the thing I wanted to discuss earlier as well. Okay. All right. Any other thing, Munja and Emma, that you would like to ask? No questions. Okay. Acha, so we were able to understand the two transformations would be stretch and translation. Okay. Let's talk about the second part. State in terms of y, f, and x, the equation of the graph shown with broken lines. Okay. Here it is. Let me just erase the other lines because otherwise. Okay. All right. So the dotted line is basically this one. You need to find the equation of this one, but in terms of x, y, and z, y, f, and x. And for this, you're not supposed to look at the graph again and again. Now we have these two important things. So now is the time that we think about our key points. Okay. So this 3 is my stretch factor. And it is along y-axis. So you guys would be, if you think about it, for y-axis, things were how they actually were. If your stretch factor was 3, this basically meant that we were multiplying 3 with the actual function, right? So if we had y equals a f of x, the stretch factor used to be a. So this is basically telling me that since my stretch factor is 3, it basically means I need to multiply this 3 with the function. So this 3 would be multiplied with the function. Okay. So for now, I know it would be y equals 3 f of x. And here I have just incorporated stretch along y. And stretch factor is 3. I'm just writing this down for you guys. This part is not, the underlined part is not important. Okay. All right. Then what else happened? Okay. Other than this, our graph shifted 4 units to the right. So the translation vector and the actual graph are basically the mirror images. Like it would look exactly the same. If my blue graph has moved 4 units to the right, which it genuinely did, 1, 2, 3, 4, then in this case, in my translation vector, I would write down 4, 0. But this was for x. And whenever something is being done for x, just know it would be other way around, right? So in the actual function, we would not be having x plus 4. We would be having x minus 4. This is what we have talked about, okay? In the key point, it was something of this type. Whenever it would be x minus a, whenever we would be subtracting something from x, the translation vector would be a0. Why was it a0? Because for minus, my graph was actually shifted a units to the right. Okay, so again we have 4, 0 here. So for this 4, I'll be writing down f of x minus 4. So this would be y equals 3 into f of x minus 4, and this is going to be the answer. Now let me just stop at this point. Yes, please look at this for a minute, try understanding things, and then if you have questions, you guys can ask me. Okay, I'm here. I'm just muting, but I'm here.
Miss,
Yes.
Miss, if it was like going up and down, so then we'll be writing 3f of x in the bracket and the translation like 0 and a as Miss. Can you give me the pen
One
so I
second, one
can?
second. Yeah, one second. I am getting your question. You're saying if it was 0, 4?
Yes, Miss.
Okay.
Something like.
All right. Okay. So first of all, if it was 0, 4, then this 4 was basically making a difference along the y-axis, and this 3, it looked like it was translating, but it had nothing to do with translation. Okay, so this was 3. In that case, this entire blue graph would have been shifted to um, 4 units above. Okay, now I can't make it over here, but 4 units above, right? So for that, things would have been same. I would have written it this way: y equals 3 f of x plus 4. Now I get your point. I get your point. Your question was that first, are we supposed to multiply this 3 or write this 4, right? This was your question.
No, Miss, I was just saying that placing the f of x in the brackets.
Like this.
Like Miss, like f of x plus 4 or f of x 4.
Yes, exactly. This was your question, right? If it should be if 3 should be multiplied with f of x only or with f of x plus 4, right?
Yes, ma'am.
Okay, I'll tell you. So for this one, this blue image is basically the stretched version that you would get after stretching the f of x. Okay, so 3 has to be multiplied with f of x. If you will multiply 3 with f of x, this would give you the blue one. If you write it this, if you write it this, 1 second, just give me 1 second. Okay, all right, so I was explaining this concept, I'm sorry. Okay, so basically, if you think about it this way, it would basically be this, that you have 3 f of x plus 12, right? So this is not true. Always remember, as long as you are stretching the original function, this 3 would be multiplied with the function. And once you have stretched that thing, then that thing is moving 4 units above. So it would have been something of this type, 3 multiplied by f of x plus 4. And not with brackets, okay? Not with brackets.
Okay.
Yes, because you know what? If you do it this way, then imagine that your function would move 4 units above, and then when you will stretch it, it would get very, very big stretched. Okay, just try doing it on paper and you would understand my point better over there, because you know, then all the coordinates would basically have 4 in it, and then when you will multiply it by 3, your graph would genuinely be stretched. Okay. Yes, any
Oh,
other question?
no, miss.
Ahmed and Munja, anything that you would like to ask?
It's clear now, ma'am. Thank you.
Okay, Ahmed, any questions?
No, ma'am.
Okay, all right. Let's talk about the next graph then. Okay, now how is the question different? For the previous one, we did not have the equation. We just had the diagrams and then we tried making sense. Okay, this time around we have the equations. So let's try doing it. The graph of y equals f of x is transformed to the graph of y equals 1 plus f of 1 by 2x. Describe fully the two single transformations which have been combined to give the resulting transformation. Okay, all right. So first of all, let me just highlight those parts. It was f of x. So this has made a difference and this has made a difference. Okay, so when I'm adding this thing, it's basically this, that I'm adding 1 in the function. And here I'm multiplying 1 by 2 with x. Okay, so whenever I'm adding, subtracting, what happens? Is it reflection? For adding, subtracting something in the function or x, it is translation. Okay, whenever we are adding or subtracting something in the function or something with x, it is translation. And whenever we are multiplying something with x or y, it is stretch. So this should be written on top of translation and it would be stretch. Okay, all right. This is going to be the idea, and look at it, it's a 4-mark question. So I would advise you guys to spend good enough time, because you know Rafe's question was very valid. At times you would think that it's like this, but please always recheck that now if you will make the graph, how it would actually look. Okay, this part is important. Okay, all right. Now for stretch, what things do we need to write down? We write down the stretch factor, it's stretch. The stretch factor along what? These are the two things. And for translation, it's just the translation vector. Okay. Acha. The stretch is basically along. Yes. The stretch is
X.
along.
Right, it's
Yes. That's right. We are multiplying 1 by 2. So it would be a horizontal stretch or it would be along x-axis. Okay. So along x-axis. And you guys know, if it was y equals f of ax, the stretch factor used to be
2.
1 by a, right? 1 by a. So whatever this number is, this used to go to the denominator. So very good. So if we have 1 by 2, the stretch factor would be 1 by 1 by 2 and it would be 2 basically. Very well said. Okay, excellent. And for the translation vector, this 1 is being added where? This 1 is being added in the actual function. So can anyone write down the translation vector in the chat box?
Miss 01.
Okay. We know that for the translation vector, we have x and y. We have 2 coordinates, and since we are adding this 1 to y, so this part would remain 0 and this would become 1, and this is going to be the answer. So you would get 2 marks for this part and 2 marks for this part. Always remember, for stretch we have 3 things: the stretch factor and the direction, and for translation it's just the name of the transformation and your translation vector. Okay, so answering examiner is also important. Yes. Now ask me if you have any questions, Ahmed, Munja and Rafe.
No, miss.
Okay, Rafe, anything that you would like to ask?
No, miss.
Oh, sorry, Ahmed and Munja.
Ma'am, can you come again on the stretch factor on top there, please?
On the previous, in the previous example?
No, this one that we are doing now.
Okay.
Stretch factor 2, yeah.
Yes.
Yeah, if you can come again, please, ma'am.
Okay. All right. So one thing is clear: whenever we are multiplying something with x or the function, it would be stretched, right? Are you clear with this much idea that multiplication of a number with x or function would mean stretch?
Yes, ma'am.
Okay. For the stretch factor, this was the key point. Okay, if the equation was y equals f of ax, if you were multiplying a with x, the stretch factor used to be 1 by a. So this time
Yeah.
around we are multiplying 1 by 2 with x. This 1 by 2 is being multiplied. Okay, this 1 by 2 is my a. So if I do 1 divided by 1 by 2, this is going to give me 2.
Okay. All right. Thanks. Oh, all right.
Yes, this is the difference.
Okay.
And if, for example, if I had 1 by 2 f of x, then this basically would have meant that this is stretch along y-axis, and the stretch factor would be this number directly. Okay, so whenever
Okay.
the number was being multiplied with the function, it would be the stretch factor directly, but for x it would be the reciprocal of it.
Okay. Yeah, I understand. Okay.
Okay. All right. So let me just see if you have no more questions. This is what we discussed. Okay, let me just scroll up, and if you have anything you can ask. Otherwise, we are done with this chapter.
Miss, can you tell the past paper questions, like the variants and everything?
Oh yes, one second. For that, I don't have it over here. Let me see. While scanning, maybe I. So I did not, when I was taking the screen. Oh, how's that possible? Oh, yes, because I was using my laptop and I just, used snipping tool and I just focused on the question. Okay, because for every time when I'm picking up past paper questions, I look at the entire paper. So next time when I'll go back to those questions, I'll certainly, tell you the past paper year and everything. Okay.
Okay, miss. Miss, I'm not able to do one of the questions. Miss, can I send you?
Yes, certainly. Let me stop the recording.